Hi everyone, I'm Yoonjoo from KAIST. Today I'm presenting our paper Promptiverse, Scalable Generation of Scaffolding Prompts through Human-AI Hybrid Knowledge Graph Annotation. Different learners struggle with different parts of lecture content due to varying prior knowledge. Hence, one-size-fits-all video design in online learning cannot address the varying needs of learners. One way to alleviate learners' diverse pain points is to utilize diverse scaffolding prompts, which provide hints and ask learners about learning content. This is an example of a scaffolding prompt. The instructor asks what factorial design is and provides hints to let learners elicit more accurate knowledge. In an online learning system, diverse scaffolding prompts can support learners by facilitating their understanding, maintaining engagement, and helping them relate concepts. To successfully deal with the diverse pain points of learners, a wide spectrum of scaffolding prompts must be prepared. However, manually creating diverse prompts is impractical due to the high cost of authoring. Interviews with 4 instructors revealed 3 specific challenges in creating scaffolding prompts. First, designing multi-turn prompts to progressively give information related to target knowledge. Second, relating diverse prompts to support learners with varying prior knowledge. And third, creating prompts that can comprehensively cover the lecture. To address these challenges, we introduced Promptiverse, a scaffolding prompt authoring approach. This approach traverses knowledge graphs to automatically generate prompts with pedagogical patterns. To assist lecture designers in building these knowledge graphs, we also introduced Grannotate, a human-machine hybrid system for annotating lecture transcripts. The traversal of knowledge graph is key to addressing the previously mentioned challenges. The first challenge can be resolved by gradual traversing on a knowledge graph. Second, diverse scaffolding prompts can be produced by automatically traversing multiple entities and relations on the graph. Finally, our approach can create a comprehensive set of prompts by traversing a knowledge graph that thoroughly covers a lecture. Promptiverse uses 3 mechanisms to create diverse, natural, and educationally effective prompts. These mechanisms are for generating a single prompt, a dyad of prompts, and educationally effective prompts. A single prompt is a prompt that asks about one knowledge element, like the entity oak or the relation between oak and deciduous trees, and provides hints about entities and relationships. The most basic mechanism for generating diverse prompts out of a knowledge graph is to first derive these single prompts from triplets in the graph, a pair of entities and their relationships. Diverse single prompts can be created out of triplets. In a prompt, a knowledge element can serve 2 functions: be provided to or elicited from learners. Here, the darker one is elicited and the clearer one is provided. Based on how knowledge elements are elicited or provided, a single triplet can turn into 3 types of single prompts. As an example, the elicit entity type prompt provides an entity oak and the relation type, but elicits the entity deciduous tree as a hypernym of oak. The second mechanism generates a dyad of prompts. For more effective prompting, multiple prompts can be combined into one coherent multi-turn scaffolding prompt. To create such multi-turn prompts, Promptiverse finds 2 prompts that share an entity, as that entity would bridge the context between the prompts. Another rule is to prevent eliciting already provided or elicited knowledge element again, as asking about already mentioned information could be pointless. Finally, we devised 4 types of multi-turn scaffolding prompting mechanisms inspired Ausubel's theory about superordinate, correlative, derivative, and combinatorial learning. Ausubel's theory proposes that meaningful learning is achieved when the instructional design considers the hierarchical relationships between prior knowledge and new knowledge. This is an example of superordinate prompting. This type of learning happens when learners first learn subordinate knowledge elements and then relate that to one superordinate entity. To harness Promptiverse's potential to scalably create prompts, we designed Grannotate to support the construction of the underlying knowledge graphs. Designed based on the challenges identified from a pilot study, Grannotate lessens annotators' efforts by providing a visualization of knowledge graphs and AI-powered recommendations. Our tool has 2 representations of an annotated graph overlaid on the transcript, and a graph visualization to facilitate sense-making. Users can add two knowledge entities by selecting a portion of the text or by selecting from the entity recommendations provided as light green highlights. The user can add a relation by selecting two entities on the transcript and then specifying the relations class with the help of system's recommended classes. When the user selects one of the classes like compare, a prompt sample is generated to help the user understand how the selected classes will be used in prompts. Finally, when the user selects one entity, edge existence recommendations are provided as light blue edges. The recommendations all aim to alleviate the burden of having too many candidate options for entities and relation classes. All annotated entities and relations are also visualized in the graph. To provide entity and relation existence recommendations, we use the SIGCHI++ framework and SciRC dataset. Our relation class recommendation is enabled by a GPT-Neo-based classification model. Specifically, we adopted the pit-tuning approach trained with our own dataset of 180 samples from 5 different lecture domains. To assess if Promptiverse and Grannotate lead to the scalable generation of diverse scaffolding prompts, we conducted a series of experiments with 24 participants. First, we compared the quality and quantity of prompts from Promptiverse and Grannotate and those created manually. Promptiverse with Grannotate generated 40 times more prompts than manual designing while showing similar prompt quality according to the evaluation of 2 experts. Our approach also generated more diverse prompts, including many different entities, relations, and their combinations. Secondly, we compared the quantity and quality of prompts generated from our approach when users had or didn't have AI recommendations. While there was no significant difference in the number of generated prompts regarding quality, only the prompts created with recommendations were of comparable quality to manually designed prompts. While no significant difference was found in cognitive load, users with recommendations had a trend of having higher mental demand. As reported in interviews, AI recommendations could lead participants to self-reflect, which might have increased the quality of prompts. Promptiverse takes a step forward to overcoming the one-size-fits-all design of online learning. With diverse and comprehensive prompts from Promptiverse, not only can learning systems provide prompts when learners request them, but they can also adaptively provide scaffolding prompts to elicit learners' understanding with the help of a component that recognizes learners' level of understanding. Moreover, by applying Promptiverse and Grannotate to multiple lectures, support can be provided over a course by merging the knowledge graphs of these lectures. Thank you for your listening.